Anyway, this is my mobile phone, and I'm a bit bugged because certain things it does aren't quite like I'd like them to be. And maybe Colin can tell us a couple of words on how to change this in his talk about exploitation of, well, symbian cell phones in that case. So I'm not sure that he'll be solving my problems, but maybe yours. So let's welcome Colin.
Hello? Okay. Okay, so I will tell you something about symbian security and especially about how to exploit Symbian OS and how to develop shellcode. I will skip this part. You can everybody just can read it in the slides, which are going to be for download. So the main aim of the presentation is to prove that Symbian OS can really be exploited like any other desktop or server or other mobile phone OS. As far as I know, there haven't been any public presentations or writings about this topic. So yeah, this is really the aim, just to show the possibilities. And I will provide some references for shellcode development, so show some small weaknesses in the Symbian capability system, and will show a small proof of concept, self-signing mobile malware. First, you will get a short introduction to Symbian OS, and we'll just show you what currently the security issues are. Then I will introduce you to the POSIX API, which was recently added to Symbian OS, which actually got me started thinking about researching Symbian security. A short part on stack smashing attacks, shell coding, the capability system, the proof of concept, and I will just give you some conclusions and some ideas for future work for me and you and everybody else. So since my main research focus is really mobile phone security, I always now start to put in a short rant mobile system security is really necessary. Your phone is not a phone, it's a computer, and a computer with many more network interfaces or connectivity interfaces than your average PC. And you can lose real money and really easy if your cell phone is being attacked. So it's a real issue, and some people still think whatever, I just punch in 10 numbers and make a call, and but that's not the thing anymore. It's a computer. And as far as I know, or as I guess, there are really more cell phones out there than personal computers. So if you say it's like a small area, it's not. It's cell phones are, or especially smartphones are, the thing to attack if you want to go into the math. Oops. Sorry. So the Symbian is interesting because it's really the major smartphone operating system. It really has about 50%. I think it's just a little bit lower now, but it's about 50% of the smartphone market. So not all mobile phones, of course, but really the smartphone stuff, it's really this thing. So if you want to do hardcore mobile phone security research, Symbian is your Windows XP or whatever. It's mainly used by Nokia and Sony Ericsson. It was recently bought by Nokia, so they will make it open source or make it free, something like that. Symbian is really old because it's based on the Epoch OS, which was developed by Psion some years ago. One of the interesting parts is that Symbian OS really has this it's a little bit like Linux, where you have like your OS and a different UI system. So every hardware manufacturer basically makes their own GUI. So, but underneath it's just Symbian. It's all the same. It just the GUI system just looks totally different. So many people may just don't know that it's Symbian. The three common or more known ones are Series 60 from Nokia, the UIQ from Sony Ericsson, and the probably not known at all here in Europe is MOAP from Sharp, which they make for NTT Docomo in Japan. So, and Symbian is really big. So there's just a really small collection of devices from many different manufacturers like Nokia, Sony Ericsson, Motorola, Samsung. Yeah, it's everywhere. So, okay. I will only cover Symbian OS version 9, which is the current version that's used, because before OS 9 or Symbian version 9, there was no real system security. I actually looked mostly at Series 60 3rd edition, because that's the version where they really started building security really in. In short, yeah, Symbian the Symbian kernel is multiprocessing, multi-threading, can do preemptive multitasking. You have memory protection, real-time support. It's a client, it's a microkernel with client-server architecture. Yeah, it's a single-user system, so no root, no user. It's just one user. Yeah. The interesting part, of course, is the security, and then on the Symbian security is, it's called platform security. It's basically divided in three parts. You have capabilities. So instead of users with certain rights and access levels, you just have binaries which have or libraries which have certain rights assigned to them. So depending on what application you execute, these applications have certain rights. I will talk about that later more. Then you have code signing, so all the libraries and DLLs need to be signed in order to be executed. It's also very common now on other platforms. And then you have data caging, where you just say, okay, you can only execute binaries from this directory, and processors can only write their stuff to this directory, and of course to some temp directory. So you have a nice, it's not really sandboxing, but it's a little bit like that. So, yeah. So until now, and especially with the older Symbian versions, Symbian 8, and I don't know if even 7, but mainly with Symbian version 8, you had a lot of Bluetooth worms and MMS worms. There were some Trojans, some viruses. You had several Bluetooth-based security issues. The one main thing where people really went after, which gets now of Symbian OS 9, is the capability system and the signing system, because freeware developers just thought, oh, I want to use all the nice features of my phone, but I don't want to buy an expensive certificate, and even I can buy a certificate, some features are still reserved. So they started either reflashing their devices with modified firmwares which don't have certain capabilities, or they actually add certain capabilities to the standard set of capabilities. And then other people found a nice exploit using the onboard device debugger, so they just changed some memory in kernel, so they could erase the privileges of their applications to do like file browsing on all directories. So that's basically what's currently out there. Yeah. There has been some previous work, so companies like F-Secure in particular, they publish a lot on Symbian security, especially on malware. Then you have, of course, the application and game cracker people who mostly publish reverse engineering stuff. And yeah, other security researchers like Ollie, who study Symbian security for a long time and always have published nice stuff, so they get a lot of credits. I will have at the end of the slides, which are available after the talk. There, I have all the references for, so you can look up and read. So when you start working with Symbian, you will notice Symbian is really different. There's no like Big Brother OS like Windows or Linux where you can like play with it and get used to it before you actually play with your phone. You don't have a standard API. Everything is really different compared with your like PC or server stuff. When you start getting into Symbian, you will notice people in forums will always complain because they don't understand it and it's really hard and difficult. So that's what actually kept me a long time from actually working with Symbian. And then when I heard about the OpenC, so the POSIX API release for Symbian OS, that really got me interested. And that's actually why I give the talk, because if you're familiar to POSIX programming, so Linux, Unix, Windows, of course, then you can just write applications and as you're used to, and it's a lot more fun and just, yeah. So a nice quote I found about Symbian is from Mike Rowell. He's some guy who does a lot of mobile device development. He said Symbian is the most developer hostile system he ever worked with. And that's, I also talked to other Symbian developers, and that's just like, yeah, programming is no fun. But yeah, that shouldn't keep you from trying to explore and exploit. It's just something you want to know in the beginning and don't give up in the first week. Okay, as I said, Symbian started to port all the C libraries to, or the basic POSIX libraries to Symbian OS, just to like ease the portability of applications. You can just take your Unix whatever application or at least library and recompile it for Symbian. Then basically ported libc, libm, the SSL stuff, some threading, the G library, the glib stuff. Yeah, you will all get all the nice stuff like string copy and string card, sprintf, all the old school security hazards. And yeah, if you disassemble stuff, you will see it's used. Of course, right now you still have to install the pips libraries by hand, but since developers are free to just install it together with their applications, you will not even see that it's used. The newer Symbian OS versions will just have it included. So, yeah. Yeah, So sys files, if you ever installed an application, you ever on your Symbian phone, you know what a sys file is. It's basically just an application installer package. So some essential tools you want, of course, your IDE, which is free now thanks to Nokia. A nice disassembler. Best one is IDA Pro. It understands Symbian binaries. Yeah, and you want to unpack sys files, so Sysware is a good tool. An ARM assembler. I like Linux, so I just work with a standard Linux ARM cross-compiler. Of course, USB cable charger for remote debugging. And of course, you want to use a Symbian device with Wi-Fi, so you don't spend too much time and money on your GSM UMTS connection. That's what you will need. Yeah, I mainly played with these two devices. I know they're kind of old, but the author is the same, and there's no reason why not to play with them. Especially the E61 is quite nice because it's a very, very widely spread phone. Of course, for all the hardcore users, they don't use the phone anymore for, I guess, 2 years or so. But yeah, they're good to play and experiment with. So the big question when I started was, okay, didn't really anybody play with Symbian OS security and publish anything? And I really wondered why they didn't. So for one thing, that's for sure, is because everything is like in those funky C++ style stuff. You have buffer sizes and bounds checking everywhere. Everything is in Unicode. So if you're not that experienced with security, reverse engineering, shell coding, and all the stuff, it's not fun to start with. So yeah, why the other reason why people should have or could have looked at it is because you have all this the funky stuff like MMS, Symbian syncing, many third-party applications. There's really a lot to break out there, and it's just widespread. So, and now, okay, now we have pips and OpenC, which are very new. So, that's why we're going to look at it now. And as I said before, Nokia just ported Qt to the platform. But I will not cover it. But so that's another standard library that could possibly invite people to take a deeper look. So buffer overflows on Symbian OS. Yeah. The older devices, about maybe from a year back, which all run on the mostly on the ARM version 5 cores. These don't support non-executable stack. There is no stack canary use in the compilers. So basic thing: you overwrite the return address on the stack and hijack the program counter and execute your own code. Very basic. On newer devices which run on the ARM version 6 cores, they actually have non-executable memory implemented. And it's not that it's implemented. I tried it, and you just get a code abort exception, and just simple stack overflow attacks won't work on your devices. You of course still should be able to do like return to libc or other libraries and other more advanced techniques, but I haven't tried that. That's just for other people to do. Why I still think this is it's still relevant, because there are many devices out there which just have ARM version 5 cores, and so Symbian OS only supports non-executable memory if the CPU actually supports it. So that's the thing. So now, each Symbian OS application of course, has virtual memory. The memory mapping looks like that. So you basically always have your stack at this address. Of course, you have some slight offset because there's always some initial data at the beginning. The heap is usually at this address, so that's pretty fixed. So there's no randomization or nothing. It's so if you debug and find the buffer addresses in your application on the stack, then they're there. The other nice thing about ARM CPUs is the byte order. So because in shellcode you don't want to have zeros in your strings, which you use for say attacks against string copy. So you can just leave out the leading zero, and because string copy will just add it back later. Of course, this is a very specific case, but it's a nice thing. Yeah. So, before we actually get to show you some shell coding, just a very quick overview of the ARM processor. So that's of course very common. As far as I know, Symbian only supports the ARM CPU. Of course, you can cross-compile it for the desktop for emulation. ARM has this thing that you have different caches for data and instructions. So you always have some problem with self-modifying code. I will, show you some stuff later. Yeah. Other nice thing is you have conditional code execution, so you can like write really tiny shell code and avoid a lot of zeros. Which you always don't want. So yeah, I never actually ever used compare in any of my things. So oops, sorry. Yeah. So you have a potential for zeros in ARM if you write ARM shellcode, so you want to avoid that. The program counter and stack pointer are just registers, so you can just read them, so you can very easily determine where your shellcode ends up on the stack. You don't have knobs, so you just build your own, just copy a register onto itself, so you change the processor state and yeah, do nothing. So, yeah, just as a reminder, I won't like explain the shellcode stuff too much because it's not that interesting. The slides are for download, so yeah, this is very simple part. We just call printf and sleep. Yeah, so just a visual example. I will show you the details of shell coding in a bit. So if you're familiar to operating systems, you know, like Linux and many, in the Unix operating system, normally they have the whole, most of the interface to the system with system calls, which are very nice for exploitation because calling system calls doesn't require knowing anything about DLLs. You don't have to load DLLs and stuff. But in Symbian, all the system interface works by DLL calls. So you either have to use DLL, use function calls which are stored in the basic or in the system interface DLL, the e-user DLL. Or you have to load other libraries. For most stuff, you actually can just use the stuff in e-user DLL. The nice thing here is on a specific device, a function will be always mapped at the same address, so you don't need big function lookup stuff, function lookup code, and so on. Of course, if you use stuff, if you use function from other libraries, you will always need to look them up. Of course, there are other libraries which also are at the same address, but that's normally not the case. So I started to check out which of my devices had like the same OS version, and really the same OS version is not just the same number but the same build number. So to see if we can, how easy it is to write actually really portable exploitation code. And I saw that it's always, I never found two device types which actually have the same mapping. Still, the offsets from some, still the libraries are really the same. You can see just two functions, the difference, the address difference between two function calls are the same, but they're just mapped at another address. So that doesn't bias too much. It's just So I wrote a small utility, which will hopefully put on the website, which just dumps all the stuff. So if you have Symbian device, you can just dump it out. Maybe, yeah, you find something interesting, but yeah, just for. So since we're going to need function addresses to actually call functions, we need to look them up. Because if you want to do more advanced stuff other than printf, you're going to need other libraries. And yeah, in Symbian, you actually look up functions not by a function name, but just a number. And so for exploitation, this is quite nice because instead of having big strings in your exploit, you just have small numbers and you just look them up. The pain, of course, is what number is what function, but yeah, IDA Pro knows Symbian binary, so you can just like open a binary and we'll just show you, okay, this function that has this ordinal and it's in this library. Bang, you have everything. So, yeah. Since we're going to need library loading code, I wrote a very small, compact piece of code. 276 bytes, which of course if you come from the PC world that's already a big part of an exploit, but the Symbian stuff actually gets quite big because you will basically write your stuff in C++ and will going to disassemble that and reuse that. Just another example, on the left side is the C code, on the right side is part of the assembly code, not too interesting, I already covered that. So as I said earlier, you have to, of course, always avoid zero stuff and other special characters. If you want to go to string functions, well known from all other platforms. In this case, I just changed my old 0-free decoder from Windows CE and just added another 32-bit value to just encode more bigger payloads, because you cannot just XOR your payload anymore against just one 32-bit value. If you have a certain size, you will always change something to 0 or some other value you don't want. So just 2 keys and nothing really fancy. Code will be hopefully online. Yeah. The other thing, instruction cache. That's a common problem. Or if you exploit ARM devices, because you need to decode your shellcode, you will have self-modifying code. And in the beginning, the shellcode ends up on the stack. So if you start executing on the stack will be cached. The stack is then cached in the instruction cache. And the encrypted part is cached as encrypted. So if you start decoding the payload, the decoded version will only end up in the data cache. So you have to somehow either flush the data cache or move the shellcode to some position that's not already cached in the instruction cache. So I mostly try to just move decode the shellcode to some other part of the stack. But if you have a bigger shellcode, it sometimes is necessary that you just allocate some memory on the heap and just move it there, and then it's 100% that memory is not in the instruction cache and everything works fine. I have a lot of slides, so I'm going to skip these 2 things. So Symbian the Symbian operating system is very asynchronous, so many calls do not block, so you just start something like a phone call, or and then you have to wait for a signal that it's done. So with traditional or with other operating systems, you can just like call some function, and if it returns, the job is done. On Symbian, it's not like that. So if you start some, phone call, and your exploit crashes right after that, the phone call will not proceed because if the initiating process dies before the process has started, or has started probably, or has already finished, then it will not work. So there are two simple ideas. So either you just start the background process, or the asynchronous call, and just like do an endless loop, because the asynchronous stuff is of course either in an own process that is spawned, or in another thread. So you can just do an endless loop. Of course you cannot do an endless loop if you want to do something after that, so yeah, then you just call sleep. There's two things that you can do, and it's really the asynchronous stuff in the beginning really costed me a lot of time, because I was not aware of it at certain parts of the API. So this is really something to keep in mind. So of course nobody wants to write huge huge pieces of shellcode in assembly if the original part was C++, and you have to initialize all the structures and classes. So I just started writing the payload in C++, very few small compact functions, and then I just like ran it through IDA Pro, just copy pasted the disassembly into the shellcode encoder, changed the function calls to the move and load feature functionality, because you cannot directly call the function call in your shellcode, because you don't have the mapping in the beginning, because that normally is done by the dynamic loader, which of course is not working for your shellcode. So shellcode normally just has the function addresses stored somewhere in your shellcode's data section. So you just load the function address from your data section and just move it to the program counter and execute that function. Of course, this only works if the addresses are static. If you load other libraries, you will need to first look up all the functions you want to call and save them in your data section, and then you just load them and move them to the program counter. So the active scheduler is the thing that does most of the asynchronous processing. If you play with plain OpenC or libc applications, you don't have this active scheduler running. This is mainly for testing out your own stuff, because most applications you're going to attack is Symbian applications that also have like libc stuff, so they will have an active scheduler running. But if you play with plain libc stuff, maybe you have some daemon or something that probably will not have an active scheduler, so you cannot do certain things, like especially like if you want to use the GSM API, that really requires a running active scheduler, but nobody prevents you from just starting an active scheduler from your shellcode. So the interesting part, how do we find buffer overflows? We could do some fuzzing. I will not go into detail there. In order to like do fuzzing, you of course need a remote debugger. so that you can actually debug applications on the device. Until, I think, 2 months, you had to buy a commercial version of the Nokia IDE to actually do that. Now it's completely free. So, yeah, without spending any money, you can get all the available tools. Just have to install the debug stub up TRK, and then you can just debug over USB and Bluetooth, just attach to any process, hold it in spec memory, just like you would do it with any other application on your desktop or other device. IDA Pro also offers a Symbian debugger. I haven't tried it. Apparently, by now it's working quite well. But yeah, I don't have a license for the debugging extension. So yeah, just a small screenshot, the debugger, your registers, and if you're overflowed, yeah. And then if you have a nice overflow, you will hit the program counter, and that's what we all want. So yeah, if you develop shellcode, you will have the real pain in the ass with Carbide, because you cannot just set breakpoints everywhere. So if you want to actually debug your shellcode, you need to actually mess up your shellcode so it halts at a specific position, and you can at least backtrack to the position where your shellcode failed. So you just put an invalid instruction, run it. If you don't reach it, you know it broke before. And invalid instructions are quite nice because they don't seem to mess up too much of the registers and memory, so you can just inspect everything as it is. So now we get to the more interesting stuff. The other stuff was more like an introduction. So the Symbian capability system, as I said earlier, controls what applications can access what resources of the system. And other than on other OSs, it's not like you can really you have an API-based capability system rather than a resource. So you cannot just say, okay, this users can do everything with the network interface or this application. And so in Symbian, it's a pair API, so you can say, okay, we have this calls, this application which can start a phone call, and this application gets low-level access to the AT command set of the phone. It's quite nice, yeah. But as you see, there are also some problems. The really interesting capabilities would be all files, because that basically gives you read, write, and execute access to every file in the file system. If you have that, you can do everything you want. Then other stuff, ComDD is that exact capability which you want to have if you want to talk to the modem directly. Then you have reading and writing user data. And some of these very interesting capabilities are only available to the hardware manufacturer. So the hardware manufacturer can also sign your code to allow you using these. So you have different groups of capabilities, and you say, okay, some of the capabilities can be used by the users, and the user can say, yeah, you can. This application is allowed to do this and this. Then you have this open signed online. This is an online signing system, which I will show you later, where you can sign applications for yourself, and you get a little more stuff there because it's only for your device. And for other devices, for the other capabilities, you need to buy a certificate and pay money, sometimes even per device. So if you want to put it on 1,000 devices, you have to pay 1,000 times. That's as far as it's a real pain in the ass to work with the capability stuff. So the point was, okay, let's see what we can do with the really basic capabilities. And one of the most basic capability is the network services capability, And that capability basically allows you to use the network. It's not that you can like configure a network interface, but you can open a socket and connect. So if you want, if you have an application that's just like an instant messaging client or a web browser, you need to have this capability because you want to open a socket. So you can get this very easily. That's, I think, in the least privileged group. The problem here, what I found out is I tried, okay, what do I need to actually initiate a phone call? And it turned out that the network services capability is the capability you need to actually do phone calls, short messaging, read specific data from the GSM CPU. So I think this is a great security risk because the phone interface is the interface you can actually lose money on, because if somebody breaks into your phone, he can just initiate a phone call to an expensive phone number, send short messages, and so on. So I thought, okay, what else can we do with that? Yeah, what I said, the phone call. Of course, just knowing, okay, I can do phone calls is not enough. We actually want to write a piece of shellcode that will do exactly that, just start a phone call. Always a nice demo if you say, okay, we actually can do it. The thing, what you need to do, because your instant messaging client or whatever application you attack will probably not have the mobile phone API loaded because it has no business using the mobile phone API. So the shellcode just loads the telephone DLL, looks up the function it needs. Actually, I found that you don't need to look up functions if the device is a 9.2 Symbian OS device because it's just at static addresses. And you just initiate the phone call and then do a sleep or endless loop to just prevent the thing from crashing. The actual phone call is just in C++, just these few lines. You set up, you just create an instance of this library, give it a string of the phone number, and it will happily just dial the call for you. It's just for reference, for reading later, and then you will get this nice pop-up. Of course, you still can stop it. And but for an SMS, you won't see that, and maybe you will be like, oh, whatever, maybe it's an incoming call. But if you like call a 900 number and it picks up after the first ring, you could actually use it to do real harm. But so the actual interesting thing is not to just like just start one phone call. We actually want to get more privileges on the device, and of course we want to stay on the phone because after we exploited a process, we can run our own code, but we cannot just write a binary to the file system like a rootkit and just stay there, because normal processors cannot write to the sysbin directory, so you cannot just write a Trojan dropper or a rootkit and just put it there. So there's this nice online signing system where developers can specially sign sys files or applications just so they run on their own device. So I thought, maybe we can abuse that. So we are going to abuse that. So the online signing works like that. You just compile your application, get the email that's the unique serial number of your phone, and you submit both and the set of capabilities to the online signing, and they will sign the file. and send it back to you. Of course, yeah, how do we get the email? Since we have access to the telephone API, we can actually read it. I don't know why every application should be able to read the hardware number, but we can do it. And since we want to download an application, I thought, yeah, why do we need to implement like some HTTP stuff and to actually send out the email, because we need to, of course, get the email to either the Symbian signed server or to our own malicious server, so they can do all the signing. So, okay, we can just start the web browser, give it an URL, put the pass the email as a parameter, and then the backend server signs this file and then just presents this for the user to download. So the web browser will, if it sees this file, it will just download and it will ask the user, hey, do you want to install this? So the original plan was like this. You have attack the device, extract the email, send it to the backend server. The backend server will send it to the online signing system. The signing system is protected by a very, very cheap captcha. You see here. Oh, okay. Did I show? No. Where is the cheap captcha? No, okay. So the online system is only protected by a very, very basic captcha, which is in hex only. So you can use like the cheap ass online captcha breaking service and just break the captcha, sign your backdoor, and just send it back. And the user just needs to install it. So yeah, I already told you about the unique ID. You can also just query it by pressing *#06# or look on the behind your battery. So yeah, so reading the email is actually a little bit ugly, because you have this. It's also completely asynchronous. The thing what I did, I just went to some website. I didn't actually read the API documentation. I just tried some samples. The one sample that worked, I made it nice and small, compiled it, disassembled it, and used it. Works pretty nice. This will be online, hopefully also. Starting the web browser is very small in comparison. Just save your URL. Of course, you always include some part for the email, so you don't need to some string manipulation. You can just copy it to the memory location of your URL and just overwrite the appropriate characters, and then you have a very, very small piece of code that actually launches the web browser, leaks your email to the malicious backend, and grabs the malicious binary. So I will also skip that. Of course, you have to sleep again, doing calling asynchronous functions. If you test a lot, always make sure you have a SIM card in the phone, because the GSM stack will not be running if there's no SIM card in the phone. So you'll always wonder why it didn't work, and it worked last time. The shellcode actually got quite big, so that's why I started moving stuff to the heap. So just on the two phones, just my first test pages, I just exploited an application and read out the email and sent it to my server, which also shows the user agent strings, just to test that it works. And it works nicely on the devices I tested. Okay, there we have the online signing. So that's the normal the normal screen you see if you want to sign an application. You just put in the email number, your email address, upload the binary, tell which capabilities you want, and then you have to fill out this nice captcha. Yeah, the captcha is in hex only. If you see what's written underneath, letters A to F and numbers 0 to 9. So yeah, that shouldn't be a problem to break this. Yeah, you can actually break it very easily by just using some online web service which has a nice Perl API or Python or whatever. So we don't even need to write that code. We just write our exploit, break the captcha. The funny thing is you always also need to click on a confirmation link after you uploaded something, and then you get another email with a download link. You can very easily abuse stuff like Mailinator, these nice spam trap emails, where you have everything accessible over a website. You can just tunnel everything through Tor or some other anonymizer to click on these links and download your stuff. So the signing takes about 50 to 120 seconds, but there's just some artificial delay which is implemented on the signing website. So of course you need to occupy the user with a nice looking web page until the malicious download is ready. So this is just output of the script. I don't know if my company will allow me to put that online, but yeah, it's very easily to build it yourself. Yeah. So yeah, 80 seconds. Hopefully you get a website that keeps the user that long before the screen pops up for the download. So of course, yeah, the captcha breaker is not too good. So yeah, you can just go and use multiple captcha breaking libraries or services, or just do multiple requests. Yeah, they have Symbian has some rate limiting, I think by IP and email address, but that shouldn't be a problem, I guess. So, and then after the malware is signed, the web browser will just download the sys file, and after that will just prompt the user, do you want to install it? And if you ever have installed Symbian applications you are used to, like pressing 5 times OK, yes, I want to install it, and yes, it's unsigned. Do you want to put it on your flash card or on the internal memory? And now you will also get a small. This is for developers only, but I think users will happily just press yes, because they're just used. Okay, I need to install something. Just press 5 times yes, 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 and everything is okay. As far as I know, this has been working for all the MMS viruses for, I don't know, 5 years or something, where you just get an MMS and say with some application in it. And the users are just used to do this stuff all the time, so I don't think it will really help. Of course, if you have a more security-aware user, then you don't have some of these problems at all. So what you could do, just make some website which says, oh, Symbian OS update, and the user will say, oh yeah, super update, or some game or whatever application, because the actual trick will be, since you exploit something that's maybe running in the background, the browser will just suddenly open and tell you, hey, download this exploit. Yeah, just download this exploit, and yeah. So of course you could just do some game side or something, but you could trick the user into believing that it's something good because it just came from nowhere, and that could only be the OS, of course. So I actually wrote a very small piece of malware. It actually didn't do anything. It's just something here, so I can sign it and play with this. It's just listens on a TCP port, and I can like telnet into it and give him some commands. Yeah, it is always started at boot time, which is very easy in Symbian OS, and yeah, has a cheap stealth mode. It just doesn't appear in the application list, but of course you could easily find it. It's not something fancy, but it's a very good demo. You could could just add like a very simple functions like call this phone number or reboot the device or send SMS or whatever. Of course, I did not do anything. Yeah, so actually the whole exploit to read the email, start the web browser. You need to load 3 additional libraries called 26 calls. The final shellcode was about 1.3K. Yeah, more or less 2 weeks to get it running completely. The scripting was more or less trivial. Just some numbers on the complexity. So what could you do if you abuse the online signing system? So of course auto start. Of course self update is always nice, or installation of other utilities using stuff like silent install, which is just another add-on library which you could of course easily embed into your malware. Of course, access to the phone network, access to the address book calendar, and possible location tracking and stuff like that. Unfortunately, the really cool capabilities are not available, but this is a good enough list, I guess, to cause some trouble. Defense of really cheap list. Of course, don't install vulnerable applications. Something new. I think the capability system could need a small fix where you separate the network capability, the network services capability into 2, so one for socket stuff and one for the GSM stuff. Probably this is kind of hard and will break everything else that already relies on that. Symbian should monitor their online signing stuff. I guess they do it. And last but not least, if you have a ARM version device that is based on the ARM version 6 CPU, then you probably have, or hopefully have, non-executable memory and secure against these basic attacks. Symbian OS can be really exploited like other OSs with simple buffer overflow, code injection techniques. The development, even the application development, I would say it's harder than other applications, but the shellcode stuff is not really that much harder. If you just use the appropriate tools, it's no big thing. So the Symbian sign system, which is always was said, the platform is really very secure because you don't have a chance to actually install signed malware, or malware cannot get signed, but you can even circumvent the signing stuff. Takes a lot of work, but it can be done. Another nice thing is that the return address stuff and the stack stuff is really stable. So if you have a binary and have it on different devices, all the addresses are more or less stable. Future work, I already talked about it. Do some return to libc or others techniques from other platforms to get around non-executable memory. Maybe break the capability system a little bit more, and of course find some O-days so you can actually use all the knowledge I just presented. I would like to thank some people. First Judith for sharing her Symbian OS knowledge with me. For also Ollie shared his deep knowledge of Symbian OS security, and Simon, Eric, Manuel, and Julian for giving their devices to me and for testing with with the trust I won't break him too much. So that's it. Oops, that's it. I don't know if we have time for questions, but I will be here anyway.
Yeah, a couple of questions. Please use the microphone.
Can you give an example of an application that you were able to exploit and inject your shellcode into?
No.
So you don't want to? Okay.
Hello. I would like to know, here in the back, I would like to know, have you been able to sniff existing network connections?
I haven't tried it. Yeah. So my main interest was in this research now, just to see if you can just like do code injection and execution. So I haven't tried any network sniffing and so on.
Colin, one correction. All files is not equivalent to root. TCB is equivalent to root.
Okay.
And all files doesn't give you modify access to all the files.
Oh, okay, good.
You need TCB.
Yeah, okay, thanks.
To what degree are those exploits dependent on a specific device or a specific release of the device?
No, so if you want to run the shellcode on different devices, you basically just need to change the function call addresses. So they're all just, the shellcodes all built that you have at the end of the shellcode. You have a section with the addresses, so you can easily just change them for another device. With some more work, you could write the shellcode in a way that it's completely device independent. Yeah, but I haven't looked into that. Also, completely device shellcode and completely device independence would be the basis for like stuff like worms. So yeah, I don't think it would be a good idea to have like published code that just does all that right now. Also, I just haven't looked into it, but it would be possible.
So, let's thank Colin again for his wonderful talk, and have a nice break.